Alright guys, so today we're talking about the coefficient of determination. Long story short, the coefficient of determination is r squared. Okay, and remember we had our correlation coefficient, right, from before, and that was just plain old r. So all we're doing is taking it and we're squaring it. It's really, yeah. Okay, so let's talk about this. So this is kind of the golden sentence. So what is the coefficient of determination? Well, it is the percent of the variation in the response variable. Let's just stop there. Let's go back to this picture right here. Remember, there is going to be a lot of variation from our y's. You see how none of these are exactly perfectly really lined up? There is some variation from here to here to there. You know, there is variation in our y's. So we're going to have variation in our response variable. Okay, so it's the percent of the variation in our response variable that is explained by the least squares regression line. Okay, so that is kind of confusing, but let's just keep going. So it says this compares the variation in the response variable, you know, of the responses to the variation of the predictions. Okay. It is a way to indicate how good our least squares, this is really what it is. I like to think about this. It is a way to indicate how good the least squared regression line predicts. So really, this thing right here, if you think about it, r, let's go back, r was a value between -1 and 1, right? Do you remember that? Okay, and so now we're saying, hey, if we square any of these values, our r squared is going to be a value anywhere between 0 and 1, right? Because if we square any of these, it's either going to, they're all going to become positive or be 0. So really what this is saying is we can have a number from 0 to 1 that is our coefficient of determination. And pretty much what this is saying is if we have a 1, if we have a coefficient of determination of 1, that means that there is a perfect correlation, or there is a perfect line. Remember, correlation, we're talking about linear stuff. A perfect line. Whereas if it is 0, we're saying, hey, there is no correlation. It is not anywhere close to being linear. We actually describe these as percents. So if there is if we have a coefficient of determination that is 0, we're just going to say 0%, and if it's 1, we're going to say 100%. Okay? That pen is terrible. Alright, so really just how good is this line? Okay? 0 to 1, how good is this line? And so the coefficient of determination is just this formula, and we already said it's r squared. All it is if we take our standard deviations of our y's, you know, or of our y hats, my bad, and we square those over the standard deviation of our y squared values. We could watch a Khan Academy video showing us where this comes from, but I think it's fine. Just accept the formula. It's a horrible teacher move, but just accept it. So this is the same thing, and this is r squared. Alright, that's fine. So let's look at this. So here we have we have the data values, and we have our predicted points. So we have all of our x's and y's, and our x's and our predicted ones. Okay? And so let's say we want to find our standard deviations of our y's and square them. So first thing that I would do is I would pop over to my calculator. I would go to stat. I would go to edit my lists. I'm going to clear all of these things out. Remember, you arrow up, hit the clear button, and then hit enter. And I'm going to type these in. So I have 30, 20, 26, 20.5, 16, 22, 18, and 10. Okay, so then I am going to go over to stat, because that's my favorite button. I know you can't see it. Let me see that. Okay, we go to stat, because that's our favorite button, and we want to calculate some stuff. And so I want L1, so that's where I typed everything. And we want to look for our standard deviation, which is right here, and we want to square that. So right now I'm literally just going to write down the standard deviation and put a little squared mark next to it so I can look at it. So it is 6.0883, and we want to square that. And let's do this one. So I'm going to go to stat. I want to put these numbers in a list. So I'm going to do 27.1, 25.5. Guys, I know you're probably watching this and you're being lazy and you're not typing this in. You have to be able to type this in on yourself. I'm not going to be here to type in this for you on your test or any quizzes, so get out your calculator and type this in. Okay, once I have all of those in, I'm going to hit stat. I'm going to calculate something. I'm going to hit enter. This time I've typed it in L2. And my standard deviation of my predicted ones is 4.8305. Okay, and I'm going to want to square that. Okay, and so now that we have these values, we can talk about finding our coefficient of determination. Back in. So our coefficient of determination, F, N, A. Formula, numbers, answer. So the formula right here is the y hat one, our standard deviation of our predicted y's, over the standard deviation of just our y values. And both of these need to be squared. And so right now I know that I have this value for my y hat, so I'm going to put 4.8305 on top, and I'm going to put this on the bottom, and when I type that into my calculator, I'm going to get something that looks like that. Okay, and so this is my coefficient of determination. Yay, we're able to blindly plug in values into our calculator and figure it out. So now, like, what on earth does this mean? Like, what does this mean? And so that's what we're going to talk about. So let's just go back to what the definition says at the top. Oops, wrong way. The definition up here says it is the percent of the variation in the response variable. I am literally going to copy this sentence, this right here. I'm going to use that to talk about this. So I am going to say the percent. So the percent here that I have is, oh, well, this is a new problem. It says suppose your coefficient was this. So I'm going to say, I'm literally following that sentence frame at the top for me. I'm going to say 60% of the variation. And I'm not going to say in the response variable. What is the response variable here? It says, when studying whether gas mileage can be predicted from speed. So I'm saying, hey, given my speed, can I predict my gas mileage? Does speed predict or explain gas mileage? So 60% of the variation in the response variable, which is this, in gas mileage, and then up there it says is explained by the least squares regression line for, and what is our least squared regression line? It is for, our x value is speed, and our y value is gas mileage. Okay, literally just copy this sentence because I understand that the coefficient of determination can be kind of a challenging topic that doesn't make much sense to people or kind of abstract. Literally all it's saying is, hey, how good is this least squares regression line? If it's close to 100% or close to 1, we're saying, hey, it's pretty good. This least squared regression line is pretty good if it is close to 100. And this is decent, right? So 60% of the variation of the gas mileage is explained by this least squared regression line. All right, there we go.